How do you find speed?
Distance over time.
So, I'm trying to figure out for an entire path right there. So the distance it would travel would be the circumference, which we've already discussed is 2 pi r. The t is the time it takes to go around once, that's the distance. And if you're talking about the time for repetitive motion, the time it takes for an object to do one of whatever the cycle is, that is known as the period. And the reason why I don't use tension, capital T for tension. So the period, T, is equal to 2 pi r over v. And now it's a plug and chug, so we have 2 pi times 3 divided by 7.7459. And we have 2 point something. 2.31477. Somebody's gonna tell me what the real answer is.
$2.4335.
Seconds. Questions to hear? All right, so now variations on a theme. We're going to go with the object swinging in a circle again, except this time we're not going to have a table underneath it. Let's give ourselves some running room. And two. Mass, which we have right here. This is about a 100-gram mass, and the stopper, I think, is somewhere around 32 grams. All right, so if I just let go, if there's no friction, if I just let go, the metal mass should fall and the stopper should go up. Let's see if it actually does that. Nope, there's too much friction. All right. However, as I spin it, it's sort of happening there. As I spin it, it is possible to spin it so that this mass is relatively in equilibrium and that mass is swinging around. So it's very similar to what we just did, except for the fact that this mass is not perfectly horizontal from the top of the tube. It's sagging some. So we need to take the weight into account. So drawing the picture, I've got the tube, which we will assume is frictionless for the sake of this problem. I'm going to make this angle theta. This is mass 1, mass 2. Just expanding on it, let's make this 3 kilograms and make the other one 10 kilograms. So the ratio should be roughly what we have in this situation right there. Mass 1. We've done it so many times. If you haven't done it in your dreams yet, just wait. It'll help. I really only care about the forces acting on these two masses. So this is my 1. Actually, I'm going to label it 3 and 10. All right, one of the forces acting on one of them. Either of them, both of them. Tell me a force. Acting which way on what?
On the ball of the
Okay, acting which way is it on this one then?
to the right. No. Upright.
Upright, okay. So I have tension acting that way and an angle of theta. All right, which way is it acting on the 10?
Up.
It's holding it up, the 10's not in free fall. And, okay, so we got tension done. So it's F. Tension's done, there's not gonna be another, and not gonna be friction, okay.
Normal force on the, down on the 3, right?
Down on the 3, what's pushing down on it?
Normal force?
Yeah, what's causing it? What object is causing it, is pushing down on it?
Isn't that like its own force, right? Or like the, oh wait.
Another question to ask with normal force is, what is it touching?
Yeah.
The rope. The rope.
And we are counting, that's where the tension's coming from.
So there's nothing there.
Yeah, no normal force.
Will there be gravity going down on the 10?
All right, Speeder, what you're saying, absolutely. Let's work on the language. What's acting down on the 10? Oh, looks like they're leaving you to hang.
Which means like.
There we go. Force due to gravity or
Wait,
weight. Yeah, gravity, huge topic. We're just looking at tiny little parts of it.
so the acceleration on the 3, would
Yes.
that be this way or with the rope?
No, the first way you said.
Okay. so
And
this-
that's the trick, that the most common mistake I see is assuming that it's in the direction of the rope. There is one other force acting on this.
Wait.
Yeah. All right, direction of acceleration of the 10, assume it's similar to the last problem we did.
So 0?
Yeah, so A10 equals 0. And for the 3 kilogram mass, what is the direction of acceleration? I don't know if you saw Tate's hand gesture, but it'd be nice if everybody knew it.
So it's that way, right? Okay, can you explain that to me?
It's traveling in a circle, we'll assume at constant speed. Where's the center of the circle? Is this object spinning like this, in which case that would be the center, or is it spinning like this?
Okay.
If I was able to do it horizontally, which was my intent, then the center is here.
Yeah.
So that's the direction of acceleration. And the most common mistake is to put it like that. Also, there's a racetrack problem, cars going around a curve on a racetrack, and people want to put acceleration down the ramp when it's towards the center. So that's force, coordinate axis. Axis. Anyone? Gilbert? Dominic? Pardon?
We'll do J hat is up and I hat is to the right.
And for this one?
J hat is up.
All right, so.
Or
let's
Joe
play
do
with
J
that.
hat down.
You wanna make J hat
Doesn't
down?
make J. That's what we did for the last one, right?
I think we had this.
Do
look,
whatever the last one was.
Whatever the
Keep
last
I
one
hat.
was,
Switch the J hat. Keep the I hat.
so that was J 3 hat, and that would be J 10 hat, or last time we just called it plus. All right, decomposition. Do we need to break anything up?
Yeah.
What?
The 3 kilogram mass. Or the I hat, J hat?
Friction. I mean, tension.
Tension,
Oh.
the forces. That's in the positive J hat 10, J10 hat. That's in the negative J10 hat, good there. This is in the J3 hat, good there. This is in a combination of I hat and J hat, so we need to break that one up. I got theta here, so what's gonna be the component, what's gonna be the horizontal component?
Cosine.
And the vertical,
Sine.
if one of them's cosine, I hope the other one's sine. So that tension, we got that 3 here, we got W3 acting down. We have tension cosine theta acting to the right, and tension sine theta acting up. And we're just leaving that as is. So again, I'm making the claim that these two vectors here is the equivalent of this one vector here. The equations of motion. There will be 3. Spoil it. Let's see, somebody give me one of the equations. Tanner, are you feeling more comfortable now to give it a shot?
Not at all.
Okay. You want to go for it?
I can try.
Yeah. Worst that happens is you're not right.
Right. Is that weight? No, is that tension minus weight?
Which one, oh, down there?
Yeah.
Yes. So tension minus W10.
And that equals, is it mass 10? I forgot that part. Yeah. And is the acceleration 0?
Yep.
So that's it? Let's go.
Yep, done. All right, we're cruising. All right, so that's the J10 hat equation. And we still have the I3 hat and the J3 hat. All right, got 2 more equations. Preferably someone who's not 100% comfortable, feels like they're just taking a shot. And if you're worried about being wrong, I will tell you that it might come across as sarcastic, but it's not. I mean, there's trying it and failing, you get more points in here than not just staying silent, than just staying silent. And these are the points that matter if you were borderline. It really expands that borderline range. So it does count for something. Madeline?
For the I hat, is it the FT cosine theta is equal to the mass 3 times centripetal acceleration?
Yep. And 1 more to go. You better make him do it again. All right, Dominic.
Weight 3 minus F sine theta,
FT sign.
or F sine theta is equal to M3 A.
A is to the
Oh,
right.
0.
And again, we set up our coordinate system so that one of them is parallel or anti-parallel to the acceleration, so the other equation is going to be equal to 0. All right, substitution. For what do we have an independent formula?
Weight.
Yep, and the formula for weight is,
Mass times gravitational force.
try again, take 2. Weight is a gravitational force, so we're not going to have weight equal to something
Oh, right.
times a gravitational force.
Mass times. Acceleration due to gravity. So there's.
Or if you want to avoid all that hassle, just say mg. All right. So from this first equation right here, we have the tension is equal to M10G. And for this equation right here, we get M3G minus tension sine theta equals 0. Or actually, let's go ahead and stick it to the other side. All right, so we got our substitution there and there. Oop, that should be an FT. And we have one other thing with the independent formula.
A.
Yes, what is the formula for A?
B squared over R.
Yeah. So FT cosine theta equals M3 squared over R. In terms of what you actually know, let's make this, we'll technically do the center of mass to here, we'll make that distance L. So I have three equations now. I've got this equation, and that equation. Now it's just a matter of solving it. It's just a math problem. It's a fun little math problem. So let's just sort of capture what we have so far, write them in a slightly better order. So tension is equal to M10G. I'm just going to go ahead and substitute that in. So I got M3G equals M10G sine theta. And M10G cosine theta equals M3V squared over R. Now what? See, my unknowns, I don't know theta, I don't know V, I don't know R. I have three unknowns. And also, R's not even given to us.
Could you divide N3 by on both sides of the first equation? So that way, no. Divide G on both sides of the equation, so it'll be
Yep.
N3 equals M10 times sine cosine.
All right, so now we have sine of theta is equal to M3 over M10. And fortunately, M3 over M10 is less than 1, because if it were greater than 1, it'd be an impossible problem. In other words, if the hanging mass were less than the spinning mass, then in a frictionless situation, there's no way that spinning it would help. Now what? It gets kind of tricky here.
Plug in M3 and M10 using that equation.
Plug in what?
Because we already know that. Never mind.
Okay.
Should we set it to 0?
Set what equal to 0?
We get sine theta minus the M3 over M10 equals 0.
We could, but
Sulfur,
I don't see where that helps us.
divide M10. Sulfur theta. Sulfur theta. Arc sine of 3.
What a license speed, 0.3. Okay, so we can find that angle.
Where did 0.3 come from?
The mass of the 3 kilogram mass over the mass of the 10
Oh,
is,
okay.
is 0.3. I just didn't feel like writing.
Okay.
All right, so on a calculator, you could solve that, find theta, plug that into here. So what is the cosine of the arcsine of 0.3?
0.3047.
So that becomes 0.3047.
Oh, cosine. Oh,
The cosine of the arcsine of 0.3.
.9539.
All right. So we can still go through. I don't know the speed and I don't know R. How do we deal with that? We're studying an equation. I know L. How do I find R?
Wait, couldn't we have just divided m10 on the second equation? So that would be g times cosine theta equals m3 b squared over m10 times r. That would be g cosine theta equals sine theta v squared over r.
Okay. That is 0.3, that was 0.9 something. 9539. G, let's put it on Earth 2, that's 10. We still are left with this V and R that we need to somehow resolve. Okay. What is R? Not asking for a number, asking for conceptually in the problem, what is R?
The radius of mass 3.
Of the circle that it creates.
Yeah.
All right, so it's the distance from